Welcome to the MP Support YouTube channel. Today we will talk about software engineering job roles. The provided images outline various professional roles within the technology landscape, categorized into software engineering and data science and AI. The first image highlights core development roles such as front-end, back-end, and full-stack engineers, alongside specialized positions like DevOps, security, and embedded systems engineers, and leadership roles like software architects and team leads. The second image focuses on the AI domain, featuring core roles like machine learning engineers and AI engineers who build and deploy intelligent systems, as well as specialized roles including data scientists, big data engineers, and AI ethicists who ensure that data-driven solutions are scalable, insightful, and ethically sound. Together, these roles represent the end-to-end lifecycle of modern digital products, from designing user interfaces and managing server-side logic to developing advanced predictive models and maintaining robust data infrastructures. Now let's talk about those job roles in depth separately. Let's first talk about front-end engineer. A front-end engineer is a specialized professional within software engineering who focuses on the client side of a web application. Essentially everything a user sees, touches, and interacts with in their browser. Their primary responsibility is to bridge the gap between visual design and server-side logic, transforming static UI/UX mockups into functional, interactive, and responsive digital experiences. This role requires a deep mastery of core web technologies such as HTML for structure, CSS for styling and layout, and JavaScript for implementing complex logic and interactivity. Modern front-end engineers often utilize powerful frameworks and libraries like React, Angular, or Vue.js to build scalable applications, while also managing state, handling API integrations, and ensuring cross-browser compatibility. Beyond just writing code, they are guardians of the user experience. They must optimize performance to ensure fast loading times, implement accessibility standards so the web remains inclusive, and ensure that the application looks seamless across various devices, from desktop monitors to smartphones. In a collaborative environment, they work closely with UI/UX designers to maintain aesthetic integrity and back-end engineers to ensure the seamless flow of data, making them a vital link in the software development lifecycle. Now let's talk about back-end engineers. A back-end engineer is a software professional who focuses on the server side of an application, dealing with the hidden logic, databases, and architecture that power the user experience from behind the scenes. While the front-end engineer builds what the user sees, the back-end engineer is responsible for the core functionality, ensuring that data is processed correctly, stored securely, and delivered efficiently to the front end. Their work primarily involves writing server-side logic using languages such as Python, Java, Node.js, Ruby, or Go, and managing databases like PostgreSQL, MongoDB, or MySQL. They are the architects of the system's infrastructure, designing APIs, application programming interfaces, that allow different software components to communicate with each other seamlessly. Key responsibilities include implementing business logic, managing user authentication and authorization, and optimizing the server for maximum speed and scalability to handle thousands of concurrent users. Back-end engineers also focus heavily on security, protecting sensitive data from breaches and ensuring that the system remains stable and reliable under heavy loads. By working closely with front-end engineers and DevOps teams, they ensure that the entire ecosystem of a web or mobile application is robust, secure, and capable of growing alongside the business needs. Now let's talk about full-stack engineers. A full-stack engineer is a versatile software professional who possesses the comprehensive skills to handle both the front-end, client-side, and back-end, server-side, development of an application. They are essentially all-rounders in the tech world, capable of building a digital product from the ground up, starting from the user interface that people interact with, down to the database logic and server configuration that powers it. On the front end, they use languages like HTML, CSS, and JavaScript, often with frameworks like React or Angular, to create seamless user experiences. Simultaneously, they manage the back end using technologies such as Node.js, Python, or Java, while designing and querying databases like PostgreSQL or MongoDB. What makes a full-stack engineer particularly valuable is their holistic understanding of the entire software development lifecycle. They can navigate the full stack of technologies, allowing them to troubleshoot issues across the entire system, bridge communication gaps between specialized teams, and rapidly prototype new features. While they may have a preference or lean toward one side, Their ability to oversee the architecture of an entire web application makes them highly efficient in agile environments and startups where flexibility and broad technical knowledge are critical for success. Now let's talk about mobile application engineers. A full-stack engineer is a versatile software professional who possesses the comprehensive skills to handle both the front-end, client-side, and back-end, server-side, development of an application. They are essentially all-rounders in the tech world, capable of building a digital product from the ground up, starting from the user interface that people interact with, down to the database logic and server configuration that powers it. On the front end, they use languages like HTML, CSS, and JavaScript, often with frameworks like React or Angular, to create seamless user experiences. Simultaneously, they manage the back end using technologies such as Node.js, Python, or Java, while designing and querying databases like PostgreSQL or MongoDB. What makes a full-stack engineer particularly valuable is their holistic understanding of the entire software development lifecycle. They can navigate the full stack of technologies, allowing them to troubleshoot issues across the entire system, bridge communication gaps between specialized teams, and rapidly prototype new features. While they may have a preference or lean toward one side, their ability to oversee the architecture of an entire web application makes them highly efficient in agile environments and startups where flexibility and broad technical knowledge are critical for success. Now let's talk about DevOps engineers. A DevOps engineer is a critical software professional who bridges the gap between software development, dev, and IT operations, ops, to shorten the system's development lifecycle and provide continuous delivery with high software quality. Their primary mission is to automate and streamline the processes involved in building, testing, and deploying software so that updates can be released faster and more reliably. They are experts in CI/CD, continuous integration and continuous deployment pipelines, using tools like Jenkins, GitHub Actions, or GitLab CI to ensure that code changes are automatically validated and integrated. Beyond just automation, DevOps engineers manage cloud infrastructure, often using AWS, Azure, or Google Cloud, and utilize infrastructure as code, IAC, tools like Terraform or Ansible to manage servers programmatically rather than manually. In addition to technical implementation, a DevOps engineer is a cultural advocate for collaboration and shared responsibility within a tech organization. They focus heavily on monitoring and logging using tools like Prometheus or ELK Stack to track system performance and detect issues before they affect the end user. By implementing containerization technologies like Docker and Kubernetes, they ensure that applications run consistently across different environments, from a developer's laptop to a massive production server. Ultimately, their role is to create a robust, scalable, and secure environment where developers can focus on writing code while the system handles the deployment and scaling automatically. Now let's talk about data engineers. A data engineer is a specialized software professional responsible for designing, building, and maintaining the complex infrastructure that allows organizations to collect, store, and analyze massive amounts of data. While data scientists focus on finding insights, data engineers are the architects who build the pipelines that move raw data from various sources into a centralized system, such as a data warehouse or data lake. They are experts in ETL, extract, transform, load processes, ensuring that data is cleaned, formatted, and validated before it reaches end users. Their technical toolkit typically includes high-level programming languages like Python or Scala, as well as deep knowledge of big data technologies such as Apache Spark, Hadoop, and Kafka. Beyond just moving data, a data engineer ensures the entire data ecosystem is scalable, secure, and highly reliable. They work extensively with both SQL and NoSQL databases and often manage cloud-based data services on platforms like AWS, Redshift, Google Cloud, BigQuery, or Azure. A significant part of their role involves optimizing database performance and ensuring data privacy and compliance with legal standards. By collaborating closely with data analysts and AI engineers, they provide the high-quality, real-time data foundations necessary for machine learning models and business intelligence tools to function accurately. Now let's talk about embedded systems engineers. An embedded systems engineer is a specialized software professional who works at the intersection of hardware and software, designing and developing code for non-computer devices. Unlike traditional software engineers who build applications for general-purpose computers or smartphones, embedded engineers write software for specific hardware with dedicated functions, such as medical devices, automotive control units, industrial robotics, and IoT, Internet of Things, appliances. Their primary goal is to optimize software for performance, reliability, and efficiency, often working within strict hardware constraints like limited memory, low processing power, and minimal energy consumption. This role requires a deep understanding of low-level programming languages, most notably C and C++, as well as assembly language and real-time operating systems, or TOOS. Beyond writing code, an embedded systems engineer must be proficient in reading hardware schematics and using specialized tools like oscilloscopes, logic analyzers, and debuggers to troubleshoot interactions between the software and physical circuits. They are responsible for developing device drivers, managing hardware interrupts, and ensuring the system operates in real time, meaning the software must respond to external inputs within precise time limits. As the world becomes more connected, these engineers play a vital role in developing the brains behind smart technology, ensuring that the firmware is secure, stable, and perfectly synchronized with the underlying physical components. Now let's talk about security engineers. A security engineer is a specialized software professional dedicated to designing, implementing, and monitoring robust systems to protect an organization's digital assets from cyber threats, hacks, and data breaches. Their role is to build security directly into the software development lifecycle rather than treating it as an afterthought, a practice often referred to as DevSecOps. They focus on identifying vulnerabilities in code, networks, and applications through rigorous testing methods such as penetration testing and vulnerability scanning. To safeguard sensitive information, they implement advanced encryption standards, manage secure authentication protocols, and configure firewalls and intrusion detection systems. Beyond technical defenses, a security engineer is responsible for developing incident response plans to mitigate damage in the event of a successful cyber attack. They perform deep-seated forensic analysis to understand how a breach occurred and how to prevent future occurrences. Their work also involves ensuring that the company complies with international security standards and data privacy laws, such as GDPR or HIPAA. By working closely with front-end, back-end, and DevOps teams, security engineers act as the guardians of the digital ecosystem, ensuring that every line of code and every server configuration is resilient against an ever-evolving landscape of global cyber threats. Now let's talk about software architect engineers. A software architect is a high-level software engineering professional responsible for making critical, high-impact design choices and dictates the technical standards, including software coding standards, tools, and platforms. Rather than focusing on individual lines of code, an architect looks at the big picture of a system to define its overall structure and how various components, such as databases, servers, and front-end interfaces, interact with one another. They choose the appropriate architectural patterns, like microservices, serverless, or monolithic, to ensure the system meets specific business requirements. Their primary goal is to ensure that the software is scalable, maintainable, and resilient, meaning it can grow as the business expands and can be easily updated without breaking. In addition to technical expertise, a software architect acts as a bridge between the business stakeholders and the technical development team. They must translate complex business needs into a technical roadmap that developers can follow. They perform risk assessments, evaluate third-party technologies, and ensure that the chosen architecture aligns with long-term organizational goals. By overseeing the entire technical vision, a software architect ensures that the final product is not only functional but also optimized for performance and cost-effectiveness, serving as the blueprint for the entire engineering team to follow. Now let's talk about UI/UX design engineers. A UI/UX design engineer is a unique hybrid professional who combines the creative principles of design with the technical rigor of front-end engineering. Their role is divided into two main pillars: user experience, UX, and user interface, UI. The UX side focuses on the logic and research behind the product, where the engineer conducts user testing and creates wireframes to ensure the application is intuitive and solves real problems. The UI side focuses on the aesthetic and interactive elements, such as typography, color palettes, buttons, and animations. Unlike a traditional designer who only delivers static images, a UI/UX design engineer often builds high-fidelity prototypes and creates design systems, a set of reusable code components, to ensure visual consistency across an entire platform. These engineers act as the ultimate advocates for the end user, ensuring that every digital interaction is not only beautiful but also effortless to use. They bridge the gap between pure art and functional code by understanding the technical limitations of browsers and mobile devices. A UI/UX design engineer must be proficient in design tools like Figma or Adobe XD, while also possessing strong skills in HTML, CSS, and interactive JavaScript. By focusing on accessibility and emotional design, they ensure that the software is inclusive for all users and provides a premium feel that builds brand loyalty. Now let's talk about Team Lead. A team lead is a senior-level software professional who balances technical excellence with people management to guide a development team towards successful project delivery. Unlike a pure manager, a team lead remains deeply involved in the technical aspects of a project, often participating in high-level code reviews, solving complex architectural bottlenecks, and ensuring the team follows best practices in coding and testing. Their primary responsibility is to remove blockers that hinder the team's progress, whether those are technical challenges, resource shortages, or communication gaps. They act as a critical shield for their developers, managing external pressures and translating business requirements from stakeholders into actionable technical tasks. Beyond technical oversight, a team lead focuses heavily on the growth and well-being of their team members. They serve as a mentor, identifying the strengths and weaknesses of individual engineers and providing the coaching necessary for their professional development. A successful team lead fosters a healthy engineering culture built on collaboration, accountability, and continuous learning. They are responsible for sprint planning, workload distribution, and performance evaluations, ensuring that the team remains motivated and aligned with the company's strategic goals. By combining leadership vision with technical authority, they transform a group of individual programmers into a high-performing, cohesive unit capable of delivering complex software at scale. Now let's talk about quality assurance engineers. A quality assurance (QA) engineer is a vital software professional responsible for ensuring that a digital product meets specified requirements and is free of defects before it reaches the end user. Their role goes beyond simply finding bugs. They focus on the entire process of software development to improve quality and prevent issues from occurring in the first place. QA engineers utilize two primary testing methods: manual testing, where they interact with the software as a user would to find glitches, and automated testing, where they write scripts using tools like Selenium, Cypress, or Appium to run repetitive tests efficiently. They are responsible for creating detailed test plans, executing test cases, and documenting bug reports that help developers understand exactly what went wrong and how to fix it. In modern software environments, QA engineers are deeply integrated into the CI/CD pipeline, ensuring that every new feature is automatically tested for regressions, meaning they check that new code hasn't accidentally broken existing functionality. They also perform specialized tests such as performance testing to see how the system handles heavy traffic, and usability testing to ensure the interface is user-friendly. By acting as the final gatekeeper of a project, the QA engineer ensures that the software is stable, secure, and reliable, which ultimately protects the company's reputation and provides a seamless experience for the customer. Now let's talk about machine learning engineers. A machine learning (ML) engineer is a specialized software professional who sits at the intersection of data science and software engineering, focusing on designing, building, and deploying self-learning applications. Unlike traditional software engineers who write explicit rules for a program to follow, ML engineers develop algorithms that allow computers to learn patterns from data and make independent predictions or decisions. Their primary work involves selecting the right machine learning models, such as neural networks, decision trees, or clustering algorithms, and training them using massive datasets. They are experts in using libraries and frameworks like TensorFlow, Keras, PyTorch, and Scikit-learn, and they primarily code in languages like Python, R, or C++. Beyond just building models, a machine learning engineer is responsible for ML ops, which involves the productionization of these models. This means they ensure that a model doesn't just work on a laptop, but can handle millions of real-world requests with high speed and accuracy. They perform feature engineering to prepare raw data for the model and run rigorous experiments to tune hyperparameters for maximum performance. Because data changes over time, they also implement monitoring systems to detect when a model's accuracy begins to drop. By bridging the gap between theoretical data research and practical software systems, ML engineers create the intelligent features we see today in everything from voice assistants and self-driving cars to personalized Netflix recommendations. Now let's talk about AI engineers. An AI engineer is a specialized professional who focuses on the practical application of artificial intelligence, AI, to solve real-world problems and enhance software systems. While they share common ground with machine learning engineers, AI engineers often take a broader approach, integrating various AI technologies, such as natural language processing, NLP, computer vision, and generative AI into functional applications. Their work involves selecting pre-trained models, fine-tuning them for specific industry tasks, and building the necessary APIs and infrastructure to ensure the AI interacts seamlessly with the rest of the software stack. They are experts in utilizing large language models, LLMs, and tools like OpenAI's GPT, Hugging Face, or LangChain to create intelligent chatbots, automated content generators, and sophisticated decision-making tools. Beyond implementation, an AI engineer must address the ethical and operational aspects of artificial intelligence. This includes managing AI governance, ensuring data privacy, and mitigating bias within AI models to ensure fair and accurate outcomes. They work closely with software developers to optimize AI performance, ensuring that resource-heavy models run efficiently in production environments without causing latency. By staying at the forefront of rapid technological shifts, AI engineers transform cutting-edge research into scalable, user-friendly products that can perceive, reason, and learn, effectively serving as the architects of the next generation of intelligent software. Now let's talk about data scientist engineers. A data scientist is a highly analytical professional who focuses on extracting meaningful insights and hidden patterns from complex datasets to drive strategic business decisions. While they possess strong programming skills, their role is distinct from a traditional software engineer as it leans heavily into mathematics, statistics, and advanced data visualization. A data scientist spends a significant portion of their time performing exploratory data analysis, EDA, to understand data trends and using statistical modeling to test hypotheses. They are experts in using specialized tools and libraries such as Pandas, NumPy, Matplotlib, and Scikit-learn, and they frequently work in interactive environments like Jupyter Notebooks. Their ultimate goal is to turn raw, chaotic information into data stories that can predict future outcomes, such as customer churn, market trends, or financial risks. In addition to technical modeling, a data scientist must be a master of communication, as they are responsible for explaining complex mathematical findings to non-technical stakeholders. They use visualization tools like Tableau, Power BI, or Seaborn to create intuitive dashboards and reports. While a data engineer builds the pipes and an ML engineer builds the deployment systems, the data scientist is the experimenter who determines which variables matter and which models provide the most accurate answers. They must also be mindful of data ethics and accuracy, ensuring that the conclusions drawn from the data are not only statistically sound, but also unbiased and actionable for the organization's growth. Now let's talk about data analyst engineers. A data analyst engineer is a professional who bridges the gap between raw data collection and high-level business intelligence by transforming complex datasets into clear, actionable reports and dashboards. Unlike a data scientist who focuses on deep predictive modeling, or a data engineer who builds the underlying infrastructure, the data analyst engineer focuses on the here and now, interpreting historical data to explain what happened and why. Their primary workflow involves data cleaning, wrangling, where they fix inconsistencies in data, and SQL querying to extract specific information from large databases. They are experts in using tools like Excel, SQL, and Python, alongside visualization platforms such as Tableau, Power BI, or Google Looker Studio to present their findings visually. In addition to technical reporting, a data analyst engineer plays a critical role in data governance by ensuring that the information being used across a company is accurate, standardized, and secure. They work closely with department heads, such as marketing, finance, or operations, to define key performance indicators, KPIs, and track them over time. By identifying trends, anomalies, and opportunities through rigorous statistical analysis, they provide the evidence needed for leaders to make data-driven decisions. Ultimately, they act as the translators of the digital world, turning rows of abstract numbers into a clear narrative that helps a business improve its efficiency and profitability. Now let's talk about AI ethical engineers. An AI ethical engineer is a specialized software professional who ensures that artificial intelligence systems are designed, developed, and deployed in a manner that is fair, transparent, and aligned with human values. As AI models become more integrated into society, these engineers act as the moral and technical guardians of the technology, focusing on mitigating algorithmic bias and preventing discriminatory outcomes. They work at the intersection of computer science, sociology, and law, creating ethical frameworks that guide the entire development lifecycle. Their primary technical tasks include performing algorithmic audits, stress testing models for hallucinations or harmful content, and ensuring data privacy through techniques like differential privacy or data anonymization. In addition to technical auditing, an AI ethical engineer is responsible for explainable AI, XAI, which involves building systems that can provide clear, human-understandable reasons for their decisions rather than acting as a black box. They collaborate closely with AI engineers and data scientists to ensure that training datasets are diverse and representative of all demographics to avoid marginalizing specific groups. They also ensure the organization complies with emerging global regulations, such as the EU AI Act. By balancing innovation with responsibility, AI ethical engineers help build public trust in technology, ensuring that intelligence is not just powerful, but also safe and equitable for everyone. Thank you for watching the video. Wait for the next part. To watch videos like this, please subscribe to the MP Support YouTube channel and turn on notifications. Don't forget to like and comment.